everyone, we're going to define a function f by a power series as follows. We have this is f of x equals 1 plus x squared divided by 2 factorial plus x cubed divided by 3 factorial and so on till we get to x to the nth power divided by n factorial. All right, we're going to find the derivative of f of x and f of 0, and also find that y equals e to the power of x. So that's how we're going to define the functions. So let's see what we have. For this is our function, and we need to just recall what n factorial is. So n factorial equals n times n minus 1 times n minus 2 times, and then we go all the way down to 3 times 2 times 1, like that. All right. So basically, when we differentiate our function, we're going to get equals. Let me use a lighter color. So we're going to get derivative of 1 is 0 plus 1 plus derivative of x squared is 2x divided by 2 factorial plus 3x squared divided by 3 factorial and so on. So we'll just put plus dot 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 plus, now for this one, we'll just bring the n in front, so x to the n minus 1 power divided by n factorial plus dot dot dot. Simplifying this, we get this equals 1 plus 2x times 2 times 1 plus 3 x squared divided by 3 times 2 times 1 plus dot 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 plus n times x to the n minus 1 power, and the denominator is going to be this. So that's just going to be n times n minus 1 times n minus 2 dot 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 times 3 times 2 times 1. And then you have your plus dot dot dot. All right, now this simplifies to equals 1 plus x squared divided by 2, and then you would have x cubed divided by 3 and so forth, plus dot 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 plus, and then we still, this would simplify, the n's cancel. So you're going to get x to the n minus 1 divided by n minus 1 factorial. All right, plus dot dot dot. All right, now this simplifies to 1 plus x squared divided by 2 factorial plus x cubed divided by 3 factorial plus dot 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 plus x to the n minus 1 divided by n minus 1 factorial, and then finally we have x to the n power divided by n factorial plus dot dot dot. All right, this just equals our original function f of x. So that's our derivative. Our derivative is just this. I mean, I added this part, but this could be basically x to the 4th divided by 4 factorial, depending on what your n is. All right, now f of 0, so we did this part, f of 0 is just going to be, when you substitute in 0, you're going to get 1 plus 0 plus 0 plus dot dot dot, which equals 1. Since the function is its own derivative and it takes on the value of 1 at x equals 0, we suspect that the function is e to the x. So let's let y equal our f of x. Then derivative of y with respect to x equals y, and y equals 1 when x equals 0, given here. So now the differential equation is separable, so we can write this as derivative of y with 2y equals dx. All I did here is cross multiply these two. So now let's integrate both sides of the equation. We get the integral of dy divided by y equals the integral of dx. I'm going to try to still squeeze in a little bit more here. So we get ln, when you integrate this, ln of absolute value of y equals x plus c. Maybe I can squeeze it all in. All right. Now that you have this, let's write this as exponent instead of a log. So we'll write y equals e to the x. We have this plus c. So instead of that, put the k, make it a big K. That's usually what you do with exponents. And now we're going to let y is 1. So 1 equals k e to the 0 power. And that means e to the 0 is 1. So 1 equals k. Yeah, we did get it squeezed in. So basically that means, since this is true, k is 1, substitute back in the 1, and you're going to get y equals e to the power of x. I squeezed it in there, a lot of little parts, but there it is. Thank you. Have a nice day. Bye-bye.